Okay, let's look at this problem called subtree of another tree. Given the roots of two binary trees, root and subroot, return true if there is a subtree of root with the same structure and node values of subroot and false otherwise. A subtree of a binary tree is a tree that consists of a node in the tree and all of its descendants. The tree could also be considered a subtree of itself. Okay, let's try and understand what that means. So here we are given this subtree and this subtree. Now, what I'm not clear is I've given a root and I've given a subroot, and obviously this for this the answer would be no, because 4120 the 0 is not there, so it's not. Yeah, so these are two different trees, unrelated. This 4 and this 4 is not really matching, only the values match, right? So what we really want to do is for every node, this so first question would be, are the node values unique in the tree? And it says, okay, number of nodes in the root tree is in the range this, number of nodes in the range root subtree is this, root is this, root is that. Does it say anywhere about unique? Given the roots of a binary tree, root and subroot, return true if there is a subtree of root with the same structure and node values of subroot, and false otherwise. The subtree of a binary tree is a tree that consists of a node in the tree. All of that is fine. So in general, my logic is this: if I can find the two trees are equal, right? So essentially what I'm going to do is I'm going to try and find if two trees are equal or not. So what that means is, because a tree can be a subtree of itself, right? So if in this is a subtree, if I can find out if maybe I'll implement a function called equal. So I'll do this. Are trees equal? And then I'm going to pass in node A and tree node B. Okay, and let's see how to implement that slightly later. But are trees equal? And then I'll do this. If are trees equal root um, and subroot, then we return true. Otherwise, we'll check either with root dot left or with root dot right, right? We'll keep checking. So we'll keep moving in all the different directions. We keep moving down on the bigger tree and compare all its subtrees with this guy. And at some point, we will find a match. Okay. Now, ultimately, what it's coming down to is, are trees equal or not? But there is another case, which is, I mean, ultimately, you will reach a null. But okay, is it guaranteed that the subroot is not null? It has to be, right? All right. Yeah, that is fine. So I'm going to do two trees equal or not. The way for that to be is, well, if one of them is null and another is not, then it's a problem. If both null, then it's fine. So if A equals to null and B equals to null, then it's all good. Return true. Else, if any of them is null, that means one is null, another is not null, then return false. And then everything else is their value should be same. So A equals to A dot val equals to B dot val, and um, comma, the left child of A and right left child of B should be equal, and that has to happen recursively, and similarly the right childs as well. So A dot right comma B dot right, right? That's the thing. So let's run the code. It's an incompatible type. Tree node, root subroot. Why are it's not void, it's boolean. And I could essentially just add this condition here, right? So if any of these three work out, I'm happy, right? If the trees are equal, or if the subtrees are equal, or if the root dot left makes a subroot is a subtree, and so on. Yeah, so this is good. Let's run again. Compilation, let's fix that. Okay, cannot find symbol. Are trees equal? Let's copy this. Okay, run again. All right, another. Cannot read field left because parameter 1 is null. Okay, what if root is null? Yeah. So maybe we handle that case separately. Okay, the two test cases passed. Let's submit. And it works. All right.